Hello everyone, it's me Sanjay Vasu back again for another video. This time science paper for Cambridge Lower Secondary Checkpoint Paper 1, April 2020.
This is the second part of the secondary checkpoint for Science April 2020.
Question 7. This question is about the life cycle of a plant. A. These processes take place in the life cycle of a plant. Put the processes in order in which they occur in the life cycle of a plant. One has been done for you. Seed germination. So seed germination means the growing of a seed into a root and shoot, as we know here. Next is pollination. Why? So once the plant germinates and creates flowers, these need to be pollinated. Only then they can become fruits. And how do they become fruits? Fertilization. And these fruits contain seeds, which means seed formation. That's the answer. B. The diagrams A and B show two different types of seed. Suggest the method of dispersal for each type of seed. Give a reason for your answer. So the seed A is likely to be animal. Why? It has hooks on its outer layer. Why does it need hooks? It's because it needs to cling on to an animal so that it can get dispersed somewhere else after the animal shakes it off. Now for B, we can say this is wind because the plant seed are very small and feathery. Like you can see they look like feathers. So they can fly in the wind. So they can be dispersed into a different place. That's the answer. Question 8. Look at the diagram of the structure of a lithium atom. A. There are 3 electrons in a lithium atom. Number 1, how many protons are there in a lithium atom? So if there are 3 electrons, there must be the same number of protons, so there's 3. 3 protons. Now how many neutrons are there in the lithium atom? How many neutrons are there? You need to remember this actually. The mass number of a lithium atom is 7. And there are 3 protons. So neutrons will be 7 minus 3, which is 4. That's the answer. 4 neutrons. You need to remember the mass number. There's no other way to do it. B. A sodium atom contains 11 protons. Draw a structure of a sodium atom. So first we'll draw a nucleus. And we'll write 11 protons and how many neutrons? 12 neutrons. A sodium atom contains 12 neutrons. You need to remember that as well. Or you need to remember the mass number, which is 23. And we can subtract 11 protons to get 12 neutrons. So you need to remember one, either the neutrons or the mass number. And you need to remember the protons. If you remember the protons, you can get electrons. So now in the first shell, we have 2 electrons. We're going to pair these up because we need to group them into pairs. Now in the second shell, you can maximum fit 8 electrons, which we'll be doing now. In the first shell, you can only fit 2, that's why I've only drawn 2. See, as you can see, I'm drawing these electrons in pairs. Now we've drawn 2, 4, 6, 8, 10 electrons. We need one more because we need 11. So we have one more shell where we only draw one lone electron to get 11 electrons. That's the answer. Question 9. Mike investigates the strength of magnets. So he has a magnet and he's having his hand, and he sees how much paper clips are attracted. Mike puts the magnet on top of his hand, puts the bottom of his hand onto 24 paper clips, lifts his hand up, and counts how many paper clips have been attracted. And he repeats it with different magnets. Here are the results. So when magnet A and B both attracted 24 paper clips, magnet C attracted 7 paper clips, D attracted 19, and E attracted 12.
A. Mike concludes that magnet A and magnet B are both strong. He cannot conclude which of these two magnets is stronger. 1. Explain why he cannot conclude which magnet A or B is stronger. So, we can see in the data given that he puts the bottom of his hand on the 24 paper clips, and magnet A and B both attracted the same 24. So even if magnet A is stronger, for example, still it would mean that they could not find out because 24 is the maximum for the particular experiment setup which Mike has done. Therefore, we can write that both magnets have picked up the same maximum number of paper clips. And just as a side note, I'll just write that that's 24. Part 2. Describe what he could do to find out which magnet A or B is stronger. So, what is the limiting factor here? It's the number of paper clips. So, if we could increase that, then of course we'll find out at a certain point which magnet is stronger. We don't need to specify how much you need to increase because we don't know the exact strength. So, we don't know how many paper clips we need to find out a difference. But then we do know that we must have more paper clips. So, he could use more paper clips. That's pretty much the only answer here. B. Pierre repeats Mike's investigation. Here appears results. He uses the same magnets and paper clips as Mike. And of course, the magnets are A, B, C, D, E. Number of paper clips is maximum 24 because it's the same paper clips as Mike. Mike only used 24. The results are different though. We can see previously it's 24, 24, 7, 19, 12. But all of these are slightly lesser. 18, 22, 1, 13, 6. So describe one difference between the results. That's part 1. And of course, I've just said that. The difference between the results is that Pierre's results are significantly lesser than Mike's. And now for part 2, suggest why they're different. So the main reason the results could be different is, let's say Pierre has a larger hand than Mike. That's the only thing which we can actually control. Because in the experiment setup, if you see the paper clips and magnets, they both are already the same in Pierre's and Mike's investigation. The only thing that could be different is the hand. So we're using that as our variable. And what can be changed in the hand? The size of the hand is the most obvious thing, right? And this is actually why the results could be different. Because let's say Pierre's hand is larger, as I said a bit before, then the magnetic field which passes through the hand will be less, and therefore the number of paper clips attracted could be less. And that is pretty much the only obvious reason to this. Pierre's hand could be larger than Mike's. That's the answer. Let's go to question 10.
Egg white contains a protein. An enzyme digests protein in the stomach. Class 9 investigate how changing the pH affects the time it takes for the enzyme to digest egg white. The graph shows the results of the investigation. A. 1. Which pH has the shortest time of digestion? So we can see that the pH increases in the x-axis and the time increases in the y-axis. So the lowest time is the shortest time, and the lowest time is over here with pH 2. That's the answer. Number 2, the class want to be certain that they have found the shortest time. Describe 2 things the class does to be certain. So number 1 is quite simple. They can repeat this investigation to check for anomalies. They repeat the investigation to check for anomalies. And number 2, what would it be? So you can see over here that the smallest pH checked is 1 and the largest is 6. They need to check the pH after 6, which means 7, 8, 9 till 14. So it might go down that time. So we're not sure if this is actually the shortest time or it is actually shorter time in the alkali section. These are all only acidic. So they check the time for pH values greater than 6. B. 1. State 1 safety risks of using liquid with very low pH. We know one thing, acids are corrosive. So if there are very strong acids, they'll be in like pH 1 to 3. So it is really dangerous because it could corrode the skin. It's one safety risk. Could corrode the skin. That's the answer. Number 2, describe one way of reducing the safety risk. So we could corrode the skin. It's simple. We just need to wear some protective gear to make it not corrode the skin. So a safety precaution could be wear gloves and glasses or goggles and safety coat. See, state one variable the students must control in this investigation. If they must control it, they must keep the same. So when we see what they must keep the same, time to digest egg white is the dependent variable. Independent variable is the pH. But look at the egg white. Like, there could be different sizes. It could be a very small size. It could be a really big size of the egg white. It could be many eggs used, or it could be a part of one egg. So the size also matters because you have to have the same size of egg white all the time. Otherwise, it'll take more time to digest higher sizes of egg white. So we can say that same size of egg white. That's the answer.
Question 11.
Jamila and Ahmed investigate displacement reactions. They put drops of different solutions into the dimples of a spotting tile. They then add metals to each solution. So we can see we have a key here, an empty dimple are these 4 ones which have nothing in it, and if we see a curved strip here, dimple with metal and solution. A. Jamila and Ahmed look to see if a reaction takes place. Suggest what they might see if a reaction takes place. So we can see that there are 12 dimples with metal and solution. So out of these, few of them will have a reaction. And what will they see if the reaction takes place? Obviously, they will see bubbles coming out of the dimple. Bubbles escaping from the dimple. B. They record the results in a table. They put a tick if there's a reaction, like this tick, and a cross if there's no reaction, like this. Here's some results. Number 1. Complete the table to predict the results for magnesium nitrate. So if we saw the table properly, we can say that magnesium is more reactive than zinc. That means zinc will not be able to react with magnesium nitrate. It won't be able to displace magnesium nitrate. Cross. Now we don't need to put anything here because magnesium and magnesium nitrate will obviously not react because they're the same metal and they have the same reactivity. Same for these three gray boxes here. Now copper and magnesium nitrate. If you see copper nitrate and magnesium does react with copper nitrate, which means copper cannot react with magnesium nitrate, cannot displace magnesium nitrate. Now iron. If you see iron nitrate and magnesium does react with this to form magnesium nitrate and iron. These are the chemical formulas. So we see magnesium nitrate cannot react with iron either because iron has lower reactivity than magnesium. Number 2, the reactivity series shows the metals in order of reactivity. Which of the 4 metals is the lowest in the reactivity series? So we see which one of these metals reacts with none of them or reacts with very less of them. By them I mean these solutions. We can see that copper does not react at all with anything. That means that copper is the lowest. Also, if we take copper nitrate, everything, zinc, magnesium, and iron reacts with copper nitrate, which means copper is also not so reactive compared to these three. This question is very easy if you know the reactivity series.
That's the answer.
Question 12. Complete the light rays in the 3 diagrams. A. So we have a reflection here, and there is a normal line and mirror. I'm not going to show you exactly how to do it. I'm not going to show you the measurements. I'm just going to show you what you need to do to solve this question. So we have the normal here, and that has a right angle with the mirror. It always has. And the right angle means 90 degrees. Now we have an incoming ray, which we will write as I. The angle between the incoming ray and normal can be written as angle I. Now we need to make sure that when we see a reflected ray, R, we need to make sure this angle R and this angle I are equal. And by doing that, measuring the angle, we can draw a reflected ray. I don't have a protractor to measure the angle in my app I'm using, so I'm not going to do it. B. Refraction. Air and water. So air has a lower density than water. That means that when it travels through this surface from water to air, it'll bend away from the normal, like this. This is the surface. This is actually the normal, because always the normal is given in dotted lines. This is 90 degrees. It'll always bend away from the normal. Therefore, we can draw it at any angle, but it just has to be away from the normal, or this angle is greater than this angle. The refracted angle R is greater than the incident angle I. C. Now we need to complete the light rays in this, which is, because this is opaque, this light ray will not be able to pass through, but these two will be going away, and therefore light rays will pass through. We just need to extend this line all the way till there so it does not pass through. These two lines will just be able to hit the screen. Like this. This light ray over here will not be able to pass through because this object is opaque. And that is the answer. Question 13. Complete the word equation for aerobic respiration. This is quite straightforward. Glucose plus oxygen reduces carbon dioxide plus water. That's the answer. And with that, it's me, Sanjay Vasu, signing out. Bye.